Hello everyone, welcome to my channel. This is an educational channel focused on bringing to light some great theories, mostly theories of everything that some of my heroes have derived over the years and never really got any credit for their work, never got paid, but they did it anyway because they knew they were onto something. They saw it as very important to get their work out there. Today is the 212th video that we've done on the reciprocal system of theory, which was a theory originated by Dewey B. Larson back in the 20th century. And the basic idea behind the reciprocal system of theory is that we live in a universe of motion. The universe is not made out of matter, it's not made out of energy, it is made out of motion. And for Larson, because other people have arrived at that conclusion in the past, Rene Descartes, Thomas Hobbes, Arthur Eddington, and others, but Larson distinguishes himself in that regard by defining motion as the relationship between space and time. So that sets up a generalized reciprocal relationship between space and time. You can think of motion as a fraction where time or space is the numerator and space or time is the denominator. Now we know in general the most basic kind of motion that we know of is speed. Speed is, the bike is traveling at 15 miles per hour. That's 15 miles of space in 1 hour of time. Space over time. Now, we can see the reciprocal relationship if we want to double the speed. Now, we can say either the bike is moving at 30 miles an hour, that's double the speed. The bike is moving at 30 miles an hour, or we could also say that the bike is moving 15 miles in 1/2 hour. We can either double the space, or we can half the time if we want to double the speed. So that shows a reciprocal relationship between space and time. But speed is not the only kind of motion. It's just one of many kinds of motion. They are all relationships between space and time. But it becomes more complicated because Larson put together two fundamental postulates. And in his first postulate, he declares that space and time both have their coordinate aspects. That means space and time are both 3 or more dimensions. We generally recognize the multidimensionality of space, but we recoil when thinking about the multidimensionality of time. But that's exactly what Larson is proposing in his reciprocal system. Coordinate time is what he calls it. Also in the postulates, he talks about clock time and clock space. This is a scalar motion. It's a motion that has a magnitude, but it has no particular direction. And we understand clock time. The clock is always getting later and later. Time is progressing. Time is flowing. But we generally do not recognize the clock space aspect, that space is always getting farther and farther apart in no particular direction. That is the flow of space, or the progression of space. Now, we have observed this through the Hubble telescope, which tells us that all of the distant galaxies are moving away from each other, but in no particular direction. You would use, to model this, you could use a balloon and put a bunch of magic dots on it with a magic marker. You blow up the balloon, all the dots are moving away from each other. This is a way to express the progression of space. Then finally, the postulates tell us that space and time both come in only discrete units. There are minimum chunks of space and time. They're not continuous, but they come in chunks or quanta. And those chunks are very small, so they're very hard to detect. But 1 unit of space in 1 unit of time, now again, remember, space over time is speed. 1 unit of space over 1 unit of time is the speed of light. So that's 1 over 1 equals 1. And so the speed of light is 1. And for Larson, then, the speed of light is the midpoint of the universe. Half of the universe is moving faster than the speed of light, and half of the universe is moving slower than the speed of light. That goes against what Einstein said, that the speed of light was the maximum speed of the universe. That's because Einstein only knew about the part of the half of the universe that's moving slower than the speed of light. He didn't understand that there was half that was moving faster. Larson calls these the material sector, the slow side, and the cosmic sector, which is the faster side. And we make all our measurements and observations from the material sector. And so we've understood how the material sector works in terms of mechanics and dynamics, but not the cosmic sector. But because of Larson's reciprocal postulate, all we have to do to understand the cosmic sector is extrapolate, recognize that what's going on in the cosmic sector is exactly the same as what's going on in the material sector, except that the roles of space and time are reversed. So in the material sector, we see coordinate space and clock time, 3-dimensional space progressing time. But in the cosmic sector, we see 3-dimensional time and clock space, progressing space. So that's an example of how you can understand what's going on in the cosmic sector by simply reversing the roles of space and time from the known material sector. Now, today we're going over Larson's book that is called Nothing But Motion. And this book is primarily on atomic physics. And we are in chapter 17 that is called Some Speculations. So this is really, he's kind of wrapped up his discussion on all these different things about atomic physics, and he's moving into like where we're headed as in terms of the theory, like what he wants to develop over time. Just some ideas about where he wants to go, what he hasn't quite figured out yet, and so on. So we're going to start here in the middle of chapter 17. The first of these tentative new conclusions is that the muon neutrino is not a neutrino. As the theoretical development now stands, there is no place for any neutrinos other than the electron neutrino and its cosmic analog, the electron antineutrino. As it is currently known. Larson calls the cosmic sector, so obviously in the material sector you have atoms, in the cosmic sector you have cosmic atoms, but that's what Larson calls them, but legacy science generally calls them antimatter. So Larson calls it cosmic matter, but legacy science, who doesn't have that foundation theoretically, calls it antimatter. So this term electron antineutrino, for Larson, that would just be the cosmic electron neutrino. Of course, the door is not completely closed. Earlier in this volume, it was asserted that sufficient evidence is now available to demonstrate that the physical universe is, in fact, a universe of motion, and that a correct development of the consequences of the postulates that define such a universe will produce an accurate representation of the existing physical universe. It is not contended, however, that the present author and his associates are infallible, and that the conclusions which they have reached by these means are always correct. It is conceivable that further theoretical clarification may change some aspects of our existing view of the neutrino situation, but the theory as it now stands has no place for muon neutrinos. Now, that was kind of important. This is one thing that Larson discusses, is what he usually says is that the reciprocal system of theory is a correct theory. The theory is correct, but he says he is not infallible. And so his ability to apply the theory is not always correct. Okay, so that's where Larson comes down on, his the correctness. The theory of the universe of motion itself is correct, but you have to take now, if you go back into some of these earlier videos that I made, I go over the outline of the deductive development of the reciprocal system. And that's where Larson takes his postulates and he goes through a deductive process. If this, then that. If this, then that. And so he arrives at really what you would call a theoretical universe. So a universe of that he constructs by theory, and then he takes the theoretical universe and compares it to the universe that the scientists have arrived at through their observations, measurements, and hypotheses. So whether he's able to go through that deductive process correctly is a subject that he feels like he could have made a mistake that way. But the theory itself is correct. And so if you actually deduce it properly through your logic, then you will arrive at a theoretical universe that matches the actual universe. But anybody who goes through that process is subject to error. Now, also, when Larson is saying there is no place for muon neutrinos in his system, one of his colleagues or his followers, Dr. Bruce Perret, usually refers to this muon neutrino actually as what he calls the massless neutron. And that has a notation of 1/2-1/2-0. In Larson's system, you have three numbers that make up not only the subatomic particles but also the atoms, and they represent the first number is two-dimensional rotation. B, the second number is two-dimensional secondary rotation, and 3C, the one-dimensional rotation. And those are the numbers that Larson uses to identify different atoms. So, in Larson's system, basically an atom is a combination of several different kinds of motion. But it is just one thing. He uses the analogy of a curveball. A curveball has a vectorial motion, it's moving forward, but it also has a spinning motion. And so, that's an analogy of something that has multiple motions, but it's just one thing. So in Larson's system, actually Larson's first book was called The Case Against the Nuclear Atom. The atom doesn't have a bunch of parts. It's one thing, but it has identifiable motions. So in Larson's system, all of these subatomic particles and so on are different kinds of motion. They're not, you know, separate entities. Okay. As brought out in the previous pages, however, the theory does require the production of a different massless particle in the process in which the muon neutrino now appears. And the logical conclusion is that the particle now called the muon neutrino is the particle required by the theory. The massless neutron. Okay, so maybe I'm getting this reversed. Larson is calling it the massless neutron, and I guess maybe Perret is turning around and then calling it the muon neutrino. Perret does great work. He did great work. He's also passed away. But he disagrees with Larson on a number of different things. We'll eventually get into his work and some of the disagreements. But I guess this is primarily semantic. But so Larson is calling it the massless neutron, but not Perret. From the observational standpoint, this changes nothing but the name, as these two massless particles cannot be distinguished by any currently known means. On the theoretical side, the observed particle fits in very well with the theoretical deductions as to the behavior of the massless neutron. This particle should theoretically be produced in every decay event, whereas the neutrino should only appear in the last step, where separation of the residual cosmic atom into two massless particles takes place. This is in accord with observation, as the muon neutrino appears in both the pion decay and the muon decay, whereas the electron neutrino appears only in the decay of the muon. Empirical confirmation of the theoretical picture produce in the theoretical production of the massless neutrons in the earlier decay events has not yet been observed, but this is understandable. The reported products of the decay of a positive muon are also in agreement with the massless neutron hypothesis. These products are currently considered to be a positron, which, according to our findings, is M0-0-1, an electron neutrino, which is M2-2-1, and a muon antineutrino, which we now identify as a massless neutron, M2-2-0. I think that's a typo. These are both typos. The electron neutrino is actually 1/2, 1/2, -1, and the massless neutron is also 1/2, or 1/2, -1/2, 0. The positron and the electron neutrino are jointly equivalent to a second massless neutron. Their appearance as two particles rather than one is probably due to the fact that they are the products of the final conversion of the residual cosmic atom, in which the electric and magnetic rotations are oppositely directed rather than merely discrete particles ejected from the cosmic atom. It is claimed that muons also exist with negative charges, and that these decay into the antiparticles of the decay products of the positive positive muon, an electron antineutrino, and a muon neutrino. These asserted products are the equivalent of two cosmic massless neutrons. the production of such particles or of cosmic particles of any kind other than the members of the regular decay sequence as the result of a decay process is rather difficult to reconcile with the theoretical principles that have been developed. Theoretical considerations indicate that there is no such thing as an anti-meson, and that the negatively charged muon is identical with the positively charged muon, except for the difference in the charge. On this basis, the decay product should differ only in that an electron replaces the positron. Inasmuch as two of the decay particles in each case are unobservable, there appears to be a rather strong probability that their identification in current physical thought comes from the 90% of interpretation rather than from the 10% of observation that enters into the reported results. However, it is the existence of some unresolved questions of this kind that has made it necessary to characterize the contents of this chapter as somewhat speculative. On the basis of the theoretical decay pattern, the incoming cosmic atoms are eventually converted into massless neutrons and their equivalents. The problem then becomes, what happens to these particles? There are no experimental or observational guideposts along this route. We will have to depend entirely on theoretical deductions. Okay, we're going to leave it right there. Thanks for tuning in today. Keep your head up. This is mostly just speculative and very difficult material, but just let it wash over you. You might pick up a tidbit that will build your wall, build your house of understanding reciprocal system. All right, have a great day. See you tomorrow.